Hey everybody. So today we're going to solve an interesting problem, and that is, let's say you have a class of kids, and everybody wants to give every other person a high five. How many total high fives would need to happen, right? There's actually a couple of different ways to solve this problem. One is using Python. There's another way of solving this problem, which is a little bit more elegant, and it uses a mathematical formula for the sum of natural numbers. We're going to actually solve it in a couple of different methods today, and you're going to learn how each method builds into the next method. So before we get into solving this problem using generally for a large number of people in a classroom, let's start small. Let's start with a classroom where there's only 4 kids, and they're going to be high-fiving every other kid that's here. So the way you do that in the most simplest approach is by actually drawing out the kids on the board like I've done, and you just draw the lines to say first this is the first high five that happens, then the second high five, and the third high five. All right, so this kid did his job. He high-fived all 3 people. Now it's her chance, and she's going to high-five 2 more people. All right, 1 and 2. Finally, the only 2 people that have not done a high five, it's these 2. So they're going to do the last high five. There we go. So for a group of 4 kids, how many total high fives are we looking at? We're looking at 1, 2, 3, 4, 5, 6. We just simply have to add them up. And if I put that in a table format, we're going to see that the first kid does 3 high fives, the second one does 2, the third one does 1, and then the fourth one, well, he's already high-fived everybody, as you can see. So there's 4. Sorry, there's 0. The fourth kid does 0 high fives, right? And we add them up. 3 plus 2 plus 1 plus 0 is 6. So that's how you solve it for a very small group of people. But how do we solve it if there's a classroom of 40 kids or 50 kids? Let's go into the second method, that is using Python and using code. So if you want to solve this problem using Python, all we have to do is remember that for 4 children, we added 3 plus 2 plus 1 plus 0, right? You can see that there's a pattern. 3 plus 2 plus 1 plus 0. We're going to be doing something, we just have to add those 3 numbers, right? So let's start off by creating a variable called the number of handshakes. That's 0 handshakes so far. Then we need to create a loop that runs 4 times. 3 plus 2 plus 1 plus 0, right? So when we have a loop like this in Python, it actually means that the counter is going to have 4 different values. And that is 0, 1, 2, and 3. So all we have to do is add them up, and you're going to end up with, it doesn't really matter if you're adding in which direction. So you can add 3 plus 2 plus 1 plus 0, the same as saying 0 plus 1 plus 2 plus 3, right? So we're going to add them up, and then if you want to print finally the number of handshakes, you can do that as well. So let's just see how this program runs in action. Let's see it in action. It's the same program right here. I'm going to hit the run button. We are going to arrive at 6 handshakes. That's exactly what we expected to see because we added it up ourselves. What if there's 10 kids then? 40 kids, 50 kids, right? If the number keeps increasing, sure, you can always just change this number here. If there's 40 kids, the loop runs 40 times. If there's 400 kids, the loop runs 400 times. But at some point, even the computer is going to start to take a long time to loop through and get the total number of handshakes. There's actually a better way of solving this, and let's get into that now. So before we dive into that mathematical formula way of solving this question, let's recap one thing. Adding numbers in ascending order, which is 0, 1, 2, and 3, is the same as adding the numbers in the descending order, so 3, 2, 1 plus 0, right? And you can see it on the screen here that they both lead to the same number. So 3, 2, 1, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a pattern here. They're all numbers that are ascending and descending, but they're basically a series of numbers. And in mathematics, these are called arithmetic series. So whenever you have a series of numbers that you're trying to add, you can use this technique called the sum of natural numbers. I'm going to give you the formula first, and then we're actually going to create that formula. We're going to understand why that formula works. So if you're familiar with formulas, the sum of natural numbers is the formula we're trying to work with, and that is, quite simply put, n times n plus 1 divided by 2. So what is n? Well, n is the largest number of handshakes that we have, and n plus 1 is, all we have to do for this formula to work is put n, instead of having n, we need to have the largest number of handshakes that we need to have, right? So in this case, 3 is the largest number of handshakes. So 3 times 3 plus 1 divided by 2 is 3 times 4 divided by 2. And that's 12 divided by 2. And that is actually 6. So we arrived at the answer in two different ways. Adding everything up and by using the formula, right? But why does this formula work? And what is this formula? And how do we create this formula from scratch? That's what we want to do next. So the question is, how does this formula work? So we know that previously what we did is, in order to get the sum, we added all the numbers in the ascending order, which is 0 plus 1 plus 2 plus 3. Adding 0 to anything is going to be, it's not going to make an effect, right? So I'm just going to remove 0 from my equation for now. And you can see that, let's say the sum is the addition of numbers going from 1 all the way to n. N can be anything. N can be 100, n can be 1,000, 10,000, it doesn't really matter, right? But using n helps us to simplify and create the formula that we're looking at here. That is the n times n plus 1 divided by 2 formula, right? That's the sum of natural numbers. So we're adding 4 numbers, 1, 2, 3, 4, all the way up to n. But if you want to get one number, 1 less than n, what do? N minus 1. If you want to get 2 less than n, you do n minus 2. If you want to get 3 less than n, you say n minus 3. Now, we know that adding numbers in the ascending order is the same as adding numbers in the descending order, right? So let's take a look at this. The sum in the reverse order is the same as the sum in the ascending order. So what if I add both of them together? Let's make it a little larger. If I add both of them together, I'm going to get 2 times the sum, because 2 sums is 2 times the sum. And then I'm going to get n plus 1. And the reason why I get n plus 1 is because I added n plus 1. I'm going to get n plus 1 again because I added 2 plus n minus 1. So 2 minus 1 is 1. So n plus 1. And we're going to again get n plus 1 one more time because n plus 3 minus 2 is n plus 1 again. N plus 4 minus 3 is n plus 1. And then so on and so on and so on until the very last number, because n plus 1 is again n plus 1, right? N minus 1 plus 2 is also going to be n plus 1. So you're starting to see a pattern here. You're seeing that every number that we're adding here is n plus 1. And how many n plus 1s are there? There's actually n plus 1s, because we go from 1 all the way up to n. That is n times n plus 1. So if you simplify this one more time, n times n plus 1 is the same as 2 times the sum. If I divide both sides of the equation by 2, what do we get? N times n plus 1 divided by 2 is the same as 2 times the sum divided by 2. Are you starting to see where that formula is coming from now? Finally, sum, if you take away 2 from the left side of the equation, you can end up with sum. Sum is n times n plus 1 divided by 2. That's how you end up with the formula. Now let's see this formula in action. Okay, let's actually solve it with numbers. Instead of using n, why don't we go back to our example, and we know that the most number of handshakes that can happen is 3, and that's the first largest number of handshakes. So the sum is going to be 1 plus 2 plus 3, and we know that if you add numbers in the other order, it's going to be the same, right? So sum is 3 plus 2 plus 1. So if you add the top equation with the bottom equation, you're going to end up with 2 sum, which is 4 plus 4 plus 4. And that's sum times 2 is equal to 12. And that's 12 divided by 2. You're going to end up with 6, which is the same as what we counted with our, drawing it out. This is 4. This is 4 because if n is 3, you're going to end up with n plus 1, and that's 4. Recall this one. If n is 3, you're going to end up with n plus 1, right? So you have n over here, 1 over here, n minus 1 over here, n minus 2 over here, 3, 2, 1, right? That's why you're going to end up with n plus 1. And means the most elegant and the effective way, that means the most elegant way for us to solve this is simply by plugging in the formula. So let's go ahead and do that. So we know that sum is n times n plus 1 divided by 2. We also know that n in this example is 3. So instead of using n, let's put 3 in its place. Sum is 3 times 3 plus 1 divided by 2. So simplify that further. You're going to end up with 3 times 4 divided by 2. Then you're going to end up with 3 times 2. And that's the same as the sum that we have been finding in both of the approaches before. To recap, we solved this problem using 3 different techniques. The first one is simply by drawing it out, putting lines to all the handshakes or the high fives that need to happen, and count them. But if you have a larger number of people, like 40 students or 60 students or 80 students, it's going to be very hard. It's going to look like a crazy spider web, and we will probably get the number wrong because we would miss a line here or there, right? So the second way of solving it is using Python. But this doesn't mean it's the fastest way, because if there's even larger number of people, let's say in Canada wants to high five or handshake every other person, right? That's a pretty large number, and the computer has to crunch all of that. If everybody on planet Earth wants to high five or handshake everybody else, right? Also a very large number. It's going to take quite a long time to do it. So the third way, and the most elegant way, is using the sum of natural numbers. So this would be the most elegant way for us to solve that number. In math is fun and easy if you know what patterns to look for. This is one pattern. Hope you enjoyed it. Thank you.